This conference will now be recorded.
Hello friends, and once again welcome to BISP Solutions. My name is Amit, and since we are learning financial modeling with Oracle EPM and NetSuite, in today's example I'm going to talk about financial modeling case with Python, and this code subsequently we call in any program or any ERP system. In today's example, first I explain you a case called amortization schedule. The code was written in Python, and subsequently we invoke this code in Excel or maybe NetSuite and Oracle EPM. So let's get started. So what is amortization schedule? In simple layman language, you have taken a loan and how you're paying a principal and interest. So I'm using a public website called EMI calculator where I've input the loan amount I've taken, the interest rate. So as of today, the currency interest rate is 8.9%. I have taken this loan for 240 months or 2 years, right? Anyway, 20 years, sorry. So the total duration of the loan, the interest rate, and a loan amount. Now, based on this input, what is my potential EMI? So I'm to pay 44,665 EMI. Out of this, the interest amount, how much I'm going to pay, and the principal amount, total interest and principal I'm going to pay into this. Okay. As you see in 50 lakh rupees loan, 57 lakh rupees interest I'm paying in next 20 years. So significantly high. When you go down over here in detail, you can see a beautiful stack bar chart. There you can see the how much principal interest you're paying month, year over year. As you see in the beginning, you pay more interest than the principal. System is calculating from current month plus one, from July month onwards. And here you can see in detail the information about how much EMI you are paying and in 46,000 rupees EMI, 46,343, 44,665, 44,665. How much principal you are paying and how much interest you are paying, right? Interest and principal, it is given over here, right? So how to perform the same calculation using Python, and we incorporate this calculation in our Oracle EPM and NetSuite, and probably we do subsequently we do analytics on top of that. Okay. So the code, I have already written the code in order to save the time. I'm going to help you interpreting the code step by step. So this is the code. Let's run this code and validate this code is working as we expected or not. So when I run this code, what I see a beautiful area chart which consists of principal and interest. Let's validate few numbers. Okay. So the first number I see over here is that the the, the interest and principal amount, right? It is around something 37,000. So first year, how much interest we are paying? Let's check. And the principal. So 37,083 interest you're going to pay, right, for 2024 first year in the month of July, and the same being shown over here, it's around 37,000, and as you're moving further your interest amount is reducing, your and principal amount is increasing, and this is shown over here in the tabular report. So the loan amount I have taken for 5 lakh rupees, and the EMI going to be 44,665, 44,665, right? It means this exactly. So my Python code is rendering numbers exactly same as EMI calculator. This is my principal. This is total payment, principal and interest. Interest is 7581, 7581, or 82. It is rounding off actually. Okay. So let's interpret this code step by step. So I'm going to remove everything from the code and we interpret this code right from the beginning. Okay. To step first, I import three libraries, Python pandas. Obviously, since we are performing a lot of numeric calculations, so I'm going to use Python pandas. And here I'm going to use some predefined interest and principal calculation function. So I use NumPy financials. And we are also going to plot this data into a chart, an area chart. So I used over here imported matplotlib. Okay. I define assumptions or a variable. They are exactly same as what I've given over here in EMI calculator. Same assumptions, right? 50 lakh rupees loan. The interest rate is 0.89. Interest rate is 0.89. And the loan is taken for 240 months. Okay. So there is a predefined function called IPMT, and I've given over here IPMT and PPMT. So which calculate interest and principal. So let's say how interest being calculated, what function is. So it's a part of your NumPy financial, and this function takes couple of arguments. The first argument takes rate. Rate is an array type, right? The rate of interest, isn't it? The second argument is a period. You're going to calculate the period, payment period. And the same thing I passed over here. If you look at my example, first I have chosen an interest rate. The interest rate given for 1 year, therefore divided by 12. Therefore, we can get a monthly interest rate. The period is the period is 240 months. Since this takes an argument, an array argument, right? The array argument. Therefore, I pass over here as a total duration of the lifespan of an loan, right? During the life of an loan. So there are 240 months I use period. Then the term is 240 months, the term and the original value. Now if you see when I run this code, and show to you what does it happen. When I run this code, system renders 240 months interest, right? Let us display this. I haven't displayed this. Print interest payment will render for 240 months. Let us run this. And we can validate one or two number, right? It ran up to 40 months. So first month interest is 37,083. 37,083. Is that correct? Yes, 37,083. So first month interest is getting calculated correctly. And the last month interest is going to be 328. 328. So the closing is 2044. 328 is rounding off to 329. Okay, we ignore the decimal place. 328.82, it is rounding off to 329. It means the interest is getting calculated for 240 months for 20 years. If I change the period, rather than giving entire array, if I give only 1 month, one period, it means system is going to calculate interest only for first period, which is 37,083. 37,083. Now the first month interest is 37,083. It means it is, in order to calculate for 20 years or 240 months, you can pass over here 240 as an array. Therefore, I use a range function starting from 1 to 241. Similarly, I use over here ANPER, the second argument ANPER, which is number of compounding period. We are calculating this for 20 years. If you want to calculate this only for 10 years, let's make it 10 years, right? So it is going to calculate for 10 years. Let's render and validate the output. So when I render this EMI for 10 year, here also a change. The loan tenure is 120 months. 10 years, actually 120 months. The correction is. When I render for 120 month, this is my first month EMI 37,083, and it is same as 37,083. Sorry, first month interest is 37,083, and last month is 464. 464. This you see 464, isn't it? It means the argument, whenever you want to perform such kind of calculation, you can simply display an individual value. This is how you can get to know how individual function work. The last argument takes the present value. Now present value I pass over as a negative value. Why? Let me make it, I put appended -1. Let us remove -1 and render this. If you remove -1 and render this, you still get the same number but with a reverse sign, right? Reverse sign. In order to eliminate this minus sign, I use appended one more minus, so we'll get a positive number. That's how you calculate interest. Similarly, you calculate principal. So let's see the IPMT, PPMT, the principal calculation. Principal calculation also takes 4 argument. I'll copy and paste principal code over here as we use interest. So I use the principal code, and now I'm going to display principal here. And we see what argument this function takes. I'm running this code and let's see what does it do. It's calculate the principal. The first principal amount is 7581. First principal is 7581 for 20 years, 240. 7581 or 82, it is rounding off. 7.81.899. So you round it off to 7.82, isn't it? So the principal and interest both calculated correctly, but the respective function IPMT and PPMT. The arguments are exactly same. You see, I pass over here a constant. Let me change it to term. It takes same argument. So first function return interest, second function return principal. How would you like to display this number? I would like to display this number in a meaningful way using a chart. Okay. So I used over here a stack plot chart, which you actually call an area chart in general, area chart. So I display the data into a stack plot chart. A stack plot takes a couple of arguments, and I want to make this data presentable in a meaningful format. So I've used a library called matplotlib and stack plot chart. Stack plot chart takes a couple of arguments: period, interest, principal, and I like to display custom messages, custom label. So interest and principal both I use. Let's run this code. The code looks beautiful, and I can see an area chart or stack plot chart, and I can see the principal and interest. But there are certain formatting issue over here since I like to calculate this only for 240 month, but the chart has taken up to 250 month, right? So it means I need to align it scaling, align it scaling, and therefore I use a scaling function over here. I like to display custom messages. So we use over here the legend. I like to display a legend on the upper left side and custom message X and Y coordinate and some format. I don't want to display 250. I want to term it over here till 240 only. So I use couple of formatting function. There are a lot of formatting function you can use it as you need it. Refer your Python documentation. So this looks significantly meaningful now, but the chart is fine. I also like to display chart is fine. I also like to display a table as well, right? As you see, the table has got a couple of elements. Interest and principal are getting calculated on the fly now. Interest plus principal going to be your total payment, right? And I also like to calculate balance. So it means your total loan amount 50 lakh rupees minus 50 lakh rupees minus you continue to decrease the principal amount month over month. So 50 lakh minus 3543582, then sorry, 50 lakh minus 3582, correct, 49 lakh 92,418, and continue to reduce the principal from the balance amount. The same calculation I have done over here this way, and therefore I'm using a table. So we use a cash flow table with a custom message, cash flow table. Okay. I like to display interest and principal, which we already calculated. Plus, what else I need? I need beginning balance, ending balance, beginning and ending balance as well. Okay. So principal interest we already calculated. Then I display the total payment you have done, which is actually this. Total payment is sum of interest plus principal. Interest plus principal. I build the code exactly based on this EMI calculator. So interest plus principal we added over here. We use cash flow table. Okay. Uh, so we added over here. Then we need to calculate ending balance. What is ending balance? Look at over here, the beginning balance and ending balance. Okay. So ending balance, as you see, the original amount you have minus principal. Original amount minus principal. Let's run this code and check. See, original amount, which is 5 lakh, minus original amount minus you pay principal. That is going to be ending balance. 5 lakh loan I have taken, and by the end of first month, I've paid 7,000 principal, 7,581 principal. So obviously, my ending balance is beginning balance minus the principal I've already paid. Now here you see one thing important. I use ending balance over here. Okay. Plus, I also like to calculate beginning balance, right? So beginning balance for the February month would be opening balance for January month, or beginning balance of second month would be opening balance for first month. How do you perform this calculation? So beginning balance, I like to say take the ending balance previous month value. Ending balance previous month value. That is one way. Okay. Or beginning balance, I take this number 5 lakh minus principal. Beginning balance minus principal equals to, and beginning balance for the first month minus principal is the ending balance for second month. This is exactly what I did. So we have original value or original balance is 5 lakh rupees, and then I am reducing ending balance for previous period. So therefore I appended minus one entails for previous, right? And finally I add a custom label, beginning balance, payment, which is sum of interest plus principal. The interest and principal we already calculated, and ending balance. So beginning balance 5 lakh minus the principal you paid, it is ending balance. This ending balance is become a opening balance or beginning balance for second month, and this continue to happen. And since we are performing this calculation for 20 months, I would like to display only 10-month data only, okay, because just to make it easy to understand. Right. So eventually your output, the one I ran into Python and the one I ran into EMI calculator, is exactly same. So this is how we can prove our code is correct. The next step, in the next video, I show you how do you call this, amortization function in NetSuite, and you can predict this for, we calculate only for current period. You can predict this based on various conditions. So we use this function, this code in Oracle Hyperion planning, and we use this in NetSuite and Oracle Fusion as well. For today, I'm going to stop over here. The code and the video I'll send across to you. Should you have any question, please feel free to reach out to bispsolution.com. Thank you very much.